Navigation under visual flight conditions may be accomplished by several methods, but navigation under instrument flight conditions can only be accomplished by the use of radio aids. This film is concerned with only one type, ADF, or Automatic Direction Finder. This is the ADF, a valuable aid to navigation. Basically, it is a high-quality radio receiver which is tuned in much the same manner as your radio at home. It consists of a lightweight receiver, a non-directional wire antenna, a directional loop antenna, an indicator, and the control unit. The ADF receiver can be operated in any one of three methods. The pilot selects the desired method with a function switch on the control unit. In the antenna position, the receiver is connected only to the non-directional wire antenna and serves as a simple radio receiver. This position is normally used for tuning and identifying the station. In the loop position, the receiver is connected only to the directional loop antenna and serves as a manually operated direction finder. The position of this antenna with respect to the station will vary the strength of the signal received. You have seen the principle of this antenna in portable radios. When the directional antenna is aligned with the station, the strongest signal is received. When it is perpendicular to the station, the signal will fade out. This is called the null. To use the receiver manually, then, the pilot rotates the loop with a loop drive switch as he listens to changes in the signal. The indicator is connected to the loop and will show the direction to the station when the loop is in the null position. In the compass position, we have the automatic direction finder. In this position, the combined signals of both the directional and the non-directional antennas are fed to the receiver, and the indicator will point to the station at all times automatically. It is in this position that we will normally operate the ADF for radio navigation. The loop is linked to the ADF indicator in the cockpit, which indicates to the pilot the direction to the desired station relative to the aircraft. Remember, relative. The 0-degree position of the indicator normally represents the nose of the aircraft. The 180-degree position represents the tail. The angle measured clockwise from the nose of the aircraft to the station is the relative bearing. In this case, the station is 60 degrees to the right of the present heading. The direction-finding antenna affords a big advantage. It enables us to use radio stations that transmit a non-directional signal, provided, of course, they transmit on a frequency within the range of this equipment. There are several types of stations we can use with the ADF. Non-directional beacons called homers, low-frequency radio ranges, portable non-directional beacons, and commercial broadcasting stations. Of the different types, the low-frequency non-directional beacons and ranges are preferred because they were designed for navigational use. They identify themselves continuously. These stations transmit within the frequency band of 190 to 550 kilocycles. Commercial stations which operate in the 550 to 250 kilocycle band are usable with the ADF but have several disadvantages. They are not designed for navigation and therefore are not associated with airways or airports. They broadcast for long periods without identification, and their hours of operation are variable. The ADF is used in both rotary and fixed-wing aircraft. Here we see the antenna installation on the L-20, the non-directional or sensing antenna, the directional loop antenna in its plastic housing. On the instrument panel, we have the control unit and indicator. The control unit includes the function switch for selecting the desired function, the volume control knob, which adjusts volume and is also the on-off switch, The frequency span of this receiver is divided into 3 bands. Although calibrated in megacycles, notice it covers the desired range 190 to 1750 kilocycles. The tuning crank is used to select the desired frequency within the proper frequency band. Although the set can be tuned like your home radio, by listening to the signal, more accurate tuning is possible through the use of the tuning meter. Tune for maximum deflection. The beat frequency oscillator is used for tuning when a station does not transmit a continuous oral tone. It is further used to establish a null with this type station when using the loop manually. With the BFO switch on, a tone is created within the receiver that builds or fades with the signal received. After the receiver has been tuned, the indicator is used for locating the station. We visualize this as a scale surrounding the aircraft. We know that when we tune to a station off to the right, the needle points off to the right. If we tune to a station to our left, the needle points to the left. It always points toward the station to which the receiver is tuned. It tells you where the station is located relative to the aircraft. To determine the direction to the station, we must make use of our heading indicator. Suppose we turn the aircraft to a heading of 30 degrees, as shown in the heading indicator. A heading is a clockwise measurement from magnetic north. When we tune the ADF receiver to a station, the ADF indicator shows a relative bearing, which is a clockwise measurement from the nose of the aircraft, in this case, 60 degrees. We can see then that if we add the relative bearing of 60 degrees as a continuation of the 30-degree heading, we find the direction to the station is 90 degrees. What we have done here is to simply add the magnetic heading and the relative bearing to determine the magnetic bearing to the station. This method will always work, but in certain situations, a simpler method is used. For instance, suppose we are on a heading of 330 degrees. If we tune a station and find the relative bearing is 300 degrees, by adding the heading of 330 degrees to the relative bearing of 300 degrees, we get the sum of 630 degrees. Whenever the sum is greater than 360 degrees, we must subtract the 360 degrees to determine the direction to the station, 270 degrees. In the case of this type, instead of visualizing that the station is 300 degrees to the right of the nose, it is easier to say it is 60 degrees to the left of the nose. And by subtracting the 60 degrees from our heading of 330 degrees, we determine the direction to the station, 270 degrees. Let's look at another factor in the use of ADF. Here our heading is north 0 degrees. The ADF indicator reads 0 degrees. Our position with respect to this station is due south. Suppose we turn the aircraft to a heading of east 090 degrees. The ADF indicates 270 degrees. In this situation, we are also south of the station. In fact, we are just as definitely south of the station here as we were when heading 0 degrees with a 0-degree relative bearing. So we can see that to determine position with the ADF, we must use the heading indicator and the ADF indicator as a team. Remember, the ADF indicator simply shows you where the station is relative to the aircraft. If the station is 30 degrees to the left of the nose, then you would know that to go to the station, you would have to turn left 30 degrees. In this case, a heading of 0 degrees. Knowing the direction to the station, we know our position in relation to the station. Let's follow an instructor and student on a training flight and see the ADF being used. For checking the navigation receivers, we taxi to the prescribed ground check position. To check the ADF receiver, we tune a nearby station. We set the function switch to the antenna position. Check its operation in all three bands and tune to the proper frequency of a known station, in this case 308 kilocycles, Enterprise Homer. Check the identifier for positive identification. For fine-tuning, we set the function switch to the compass position and tune for a maximum deflection of the tuning meter. Once this is done, we check the ADF indicator to see that it gives the appropriate reading for the station used for this check. Always check this reading by driving the loop away from this position with a loop drive switch to see if it will return automatically to the same position. That checks. A further check can be made by switching to the loop position to see if we get a null in this position. Okay, we're in business. Let's call for clearance and get started.